Electromagnetic radiation is really important to the world around us. It travels as waves and moves energy from one place to another. Electromagnetic waves are made of oscillating electrical and magnetic fields. They're transverse waves and they don't need a medium to travel through. This means they can travel through a vacuum. They all travel at the same speed, 300 million meters per second, or in standard form, 3 times 10 to the 8. That's really fast, but it still takes time for them to travel from one place to the other. Like all waves, electromagnetic waves have a frequency and a wavelength. We give different ranges of frequencies and wavelengths different names, but they're all part of the same electromagnetic spectrum. At one end of the spectrum, waves such as radio waves have very long wavelengths, up to thousands of kilometers, and they have a very low frequency. At the other end of the spectrum, the waves such as gamma waves have short wavelength and high frequency. All of these waves have similar properties. They're all transverse waves, they transfer energy from one place to another, and they travel at the same very high speed in a vacuum or through space. Remember, that's 300 million meters per second. They slow down a bit when they pass through air or water or other materials. They can be reflected, refracted, and diffracted, just like any other waves. As you go along the spectrum, from radio waves through visible light to gamma rays, the wavelength gets shorter, the frequency gets higher, and the waves carry more energy. But there isn't a sudden change from one group of waves to the next. The electromagnetic spectrum is a continuous spectrum of waves. There's no gaps between the different types of waves. It's just easier to group them by their uses and their properties.